time we are looking at and compound inequalities, right? It's different than the ors. So for the ands, you're looking for numbers that satisfy both sides, not just either or. All right. For this one on the left, we've got variables on both sides. So what we're going to do, let's move all of our variables to one side first. So I'm going to minus 8x from both sides. All right. And I'm also going to want to get my regular numbers over to the other side. So I'm going to add 3 to both sides. Okay. So I got my variables on one side and regular numbers moving into the other side. All right. So the 3's can cancel. And then on the left, you've got 4x minus 8x, which is negative 4x. And then the 8x minus 8x can cancel. 5 plus 3 is just 8. We'll divide by negative 4, so we're going to have to flip our signs. Okay, x will be less than 8 divided by negative 4 is negative 2. Okay. And then on this side, variables on both sides. We could just move the 3x over to this side. You can do that if you want. I'm going to move. I like having my letters on the left, so I'm going to minus 6x from both sides. And I want my regular numbers on the other side, so I'm going to add 45 to both sides. All right, and then that's plus 45 over here, and it's like nothing plus 45, or 0 plus 45. Okay, on the left, we've got negative 3x and negative 6x, so that's negative 9x. 45's cancel. Bring down my inequality sign. 6x's can cancel. And then nothing plus 45 is 45. All right. From here, divide by negative 9. All right, we'll get x is greater than or equal to, flip the sign, and then 45 divided by negative 9 is negative 5. All right, let's see if we can make sense of this. We're looking for numbers that are less than negative 2, and they have to be greater than negative 5. All right, so let's see here. Here's 0. Here can be negative 2, and negative 5 can be over here. All right, so we've got an open dot at negative 2, a closed dot at negative 5. So the way these are going to work is they're going to be connected. We want numbers that are greater than negative 5, so going this direction, but they also have to be less than negative 2. So it's going to be negative 2 going this direction. And it's got to satisfy both of them, so it's only going to be in this little region here. So negative 3, negative 4, negative 5 you can count, but not negative 2. All right. Let's do one more. All right, so this is also an and. It's kind of a special version of an and inequality. What you have here is you have 5x minus 8 is less than or equal to 12, and you have 5x minus 8. If I'm reading this backwards, it would be is greater than or equal to negative 4. So this is a notation, instead of writing 2 inequalities, you can just write it as 1. Instead of just adding 8 to both sides, like you would here and here, you will add 8 to the middle, to the right, and to the left. All right, so we're adding it to all 3 sides now. All right, on the far left, negative 4 plus 8 is positive 4. All right, the 8's can cancel, so in the middle, you just have 5x. On the right, 12 plus 8 is 20. All right, and then we're going to divide all 3 sides by 5. So divide by 5, divide by 5, divide by 5. All right, so on the left side, you just get 4/5. Or if you want to, you can write that as a decimal. All right, so 4/5 or 0.8, it's up to you. The middle, 5's cancel, so you just have x. And then 20 divided by 5 is 4. All right, so the way this works, we'll have 0. This can be 0.8 and 4. So this says that x has to be less than 4, so going this way, and it also has to be greater than 0.8. So x is between these two numbers. All right. So we'll have closed dots at both. All right, it's got to be less than 4, so going this way. And it also has to be, if you read it backwards, it has to be greater than 0.8, so going this way. All right. And those were the and inequalities.